Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering typology subject. So in this subject, already we have learned about friction, wear, and lubrication, and also corrosion. So all these parameters involves in engineering typology. And then in previous session, the most important thing is the selection of materials. So that is engineering materials. So how to select a material for particular purpose, for particular application, that is based on their properties. So that's why every engineer should know about material properties. So then only he can select the proper material for particular design. So in this, the engineering materials are different types classified into different types of ferrous materials and non-ferrous materials. So in these different categories also there and different alloys also there. So already started this topic in the previous two sessions we have learned. So in this today's session, so once again we will see about the engineering materials introduction, and then we will enter into the main topics. So engineering materials are the fundamental substances used in the construction and then manufacturing of various products and structures. So these are the main substances used in manufacturing structures and then different construction fields. So suppose if you want to design any product, the material selection is important. These materials are selected based on their properties and suitability for specific applications. So already I told you in previous starting. So based on their properties, if you want to you have to select the material for specific application. So ranging from everyday objects to complex industrial components. So not only for a complex product, the material selection is very important from our daily life of used products to industrial products, the complex products. So the field of engineering materials encompasses a wide range of substances, including metals, polymers, ceramics, composites, and semiconductors. So the field of engineering materials, the wide range of substances are there, including in these materials, polymers, metals, and composite ceramics. That is based on the properties and the application. The material selection depends upon the application. So in this the engineering materials, the nickel-based alloys is one type of the materials. Nickel-based alloys are generally class of metallic materials. So the materials are already divided into two parts. One is metallic, another one is non-metallic. So under mechanical category, the metallic category, the nickel-based alloys comes under, and that primarily consists of a nickel as the base element. The here nickel-based alloys, the primary element is nickel. So with other alloying materials added to enhance specific properties. If you want to improve the particular property, suppose strength, hardness, the corrosion. So if we want to add some alloying materials, whenever you added other materials to the base material element, that entire metal is called as alloy. Similarly, in this nickel-based alloy, the first element, the base element is nickel, and other alloying elements we have to add to enhance the properties, improve the properties. These alloys are known for their excellent corrosion resistance, high temperature strength. It can the material alloy, these alloys withstand high temperature strength, and then often their ability to maintain these properties across a wide range of temperatures. So that you have to add some alloying elements to the base element to improve these properties. See here, corrosion resistance improved, and highest temperature strength also improved, and it can withstand high temperatures. So, the ability to maintain these properties across a wide range of temperatures. Next, composition. The main composition is nickel-based alloys typically contain significant amounts of nickel, often more than 50%. Along with the other elements are chromium, molybdenum, iron, cobalt, and other elements like titanium, aluminum, and tungsten. These are the alloying elements contribute to the alloy specific properties. So nickel-based alloy, the base element is nickel, and along with the chromium, molybdenum, iron, cobalt, and other elements. This entire the mixture alloy is called nickel based alloys. The properties are corrosion resistance and a high temperature strength. The nickel based alloys are highly resistant to the corrosion. So then only you have added some alloying elements to the base element to enhance the properties. So particularly in aggressive environments, including seawater, acids, and alkaline solutions. So it can protect the materials protect from these atmospheric elements like atmospheric properties like seawater, acids, and alkaline solutions. So whenever the product presented or exposed to the these type of environmental conditions, the product withstand from the corrosion and erosion and other destroying elements. So high temperature strength, they retain their mechanical properties at elevated temperatures. The mechanical properties already know: strength, hardness, creep, fatigue. Okay. So the malleability, these all are mechanical properties. To retain these type of properties at elevated temperatures, at high temperatures, making them suitable for applications where high strength and high temperatures is required, such as in gas turbines, aerospace components, and chemical processing plants. So where the high strength, high temperature is required, there these type of metals, nickel-based alloys is used in used in gas turbines, aerospace components, and chemical processing plants. So these all are high temperature zones. So it can the materials, the gas turbines or aerospace components are resistant from this high temperature. So then, so that these the products are made with this nickel alloy material. So other properties are wear resistance and fabricability. So some nickel-based alloys exhibit excellent wear resistance, which is beneficial in applications involving friction and wear. Some nickel-based alloys exhibit excellent wear resistance. Fabricability means they can be fabricated into various forms such as sheets, plates, tubes, and wires, and can be easily welded or machined depending on the specific alloy composition. So the materials, after adding the alloying elements, the material should withstand the temperatures and corrosion and as well as wear resistance. So all these materials are fabricability also required, that is weldability, machinability. It can be easily welded or machined depending on the specific alloy composition. So that is the properties depends upon the alloy composition. Suppose you want to weld the two materials, two metals, or to suppose if you want to do the some machining properties. So the material feasibility is required. The material is easily machinable or not, easily welded or not. Required. Otherwise, no use. Next applications. Aerospace applications used in jet engines. So high temperature zones, turbine blades, and combustion chambers, and other components where high strength and corrosion resistance are critical. Next, oil and gas. Components for down hole drilling tools, valves, and piping systems where resistance to corrosive environments and high temperatures is necessary. In oil and gas companies and aerospace applications, these materials are used. Next, chemical processing. Equipment such as reactors and vessels where resistance to corrosive chemicals and high temperature is required. So already told wherever the high temperatures is required, so there these type of alloys are used. Electronics are nickel alloys are also used in electronic components, nickel alloys, and batteries due to their electric conductivity and resistance to corrosion. Here, very important this resistance to corrosion in the case of batteries. In this chemical processing plant, the high temperatures are important. So these are the applications of nickel-based alloys, chemical processing plants and electronics. The types also there, the nickel-based alloys in Conal. So a well-known family of nickel chromium-based super alloys, known for their oxidation resistance, high temperature strength, and corrosion resistance. This family is called Inconel. Next one is Astalloy. Another series of nickel-based alloys known for their exceptional resistance to a wide variety of aggressive chemicals. So these are really exceptional case. So Astalloy series is nickel-based alloys for resistance to the wide variety of aggressive chemicals. So all varieties of aggressive chemicals can withstand Astalloy. So this material, this alloy also, the nickel-based series alloy. So overall, the nickel-based alloys are crucial materials in industries where performance under demanding conditions is required, offering a balance of high strength, corrosion resistance, and thermal stability. Their versatility and reliability make them indispensable in modern engineering applications. Next material is magnesium alloys. So these materials are metal alloys primarily composed of magnesium. The base element is magnesium and often combined with other elements to enhance the specific properties. These alloys are known for their lightweight properties, excellent strength to weight ratio, and good machinability. So these are the main properties. To enhance these properties, you have to add some other alloying elements to this base element magnesium. Here shown some key aspects of magnesium alloys composition. So the main composition is consist of magnesium as the base metal, and then with alloying elements are one is aluminum, zinc, manganese, and silicon, and rare earth elements like cerium and zirconium. So all these elements, alloying elements, add to alloying to the base element. These alloying elements are added to improve mechanical properties, corrosion resistance, and other characteristics. So improve mechanical properties, you can improve, and corrosion resistance, and other characteristics also you can improve by adding these elements to the base element. The properties are lightweight property. The magnesium is one of the lightest structural material. The making magnesium alloys highly attractive for applications where weight reduction is critical, such as in automotive and aerospace industries. High strength. Despite its low density, the magnesium alloys can exhibit good strength, especially when alloyed with elements like aluminum or rare earth metals. So these are the properties, lightweight properties and high strength properties. Other properties are good machinability, corrosion resistance. So magnesium alloys have excellent machinability, which allows for easy shaping, drilling, and milling, making them suitable for various manufacturing processes. So you want to manufacture a product. So in that involves various machining process, drilling, milling, machining, cutting, shaping. So these all are various manufacturing process. The material should be feasible for this process. So that is the material should have good machinability, good buildability. So corrosion resistance next property. The magnesium alloys can offer good corrosion resistance depending on their alloy composition. Some alloys are specifically developed to enhance resistance to corrosion in different environments. So other alloys, some alloys are there. They specifically developed to resistance to the corrosion in different environments. Next applications of these magnesium alloys in automotive structure sector and then aerospace sector. The magnesium alloys are used in automotive applications to reduce weight and improve fuel efficiency. They are used in components such as engine blocks, transmission cases, steering wheels, and interior parts. So all these materials, all these parts made with this magnesium alloys. The aerospace. In aerospace, the magnesium alloys are used for lightweight structural components, aircraft seats, and helicopter rotor blades. In aerospace case, the applications like this, and automotive applications, the magnesium alloys are used. Other applications are consumer electronics. In consumer electronics, already the laptops and phones, smartphones. So why these magnesium alloys are used for these products due to the lightweight and lightweight ratio and the durable properties. The medical devices. Some medical devices and implants benefit from the biocompatibility and lightweight nature of magnesium alloys. So challenges are flammability and corrosion. These two are very important challenges. How to overcome these challenges? Pure magnesium and some magnesium alloys are highly flammable under certain conditions, which can pose safety concerns. The corrosion, some magnesium alloys can be susceptible to corrosion, particularly in environments with high humidity or exposure to salt water. So, whenever the material is exposed to the salt water and with high humidity environment, then corrosion will be possible. So, these how to avoid to control this corrosion, this type, and how to avoid this flammability. These are the major challenges. Next, types of magnesium alloys. AZ series and W series, two series are there. This includes alloys such as AZ 31, 61 and 91 series are there, where the numbers denote the percentage of aluminum and zinc added. So how much percentage added aluminum and zinc added. That is, it indicates the 31 and 61 and 91. W series, these are the magnesium rare earth alloys, which include elements like yttrium, cerium, and zirconium to improve strength and corrosion resistance. So these W series and AZ series are used for this in this some applications. So finally, in summary, the magnesium alloys offer significant advantages in terms of weight reduction and strength, making them valuable materials in industries where lightweight and high performance materials are required. The advances in alloy development continue to expand their applications across various sectors through consultations regarding corrosion resistance and flammability remain important in their use. So these are the main materials used in industries and other sectors, nickel based alloys and magnesium based alloys. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.